Chapter 4 Understanding Ownership. Ownership is the most important and unique feature in Rust. It enables memory safety guarantees without garbage collector. So we must learn ownership and its related concepts like borrowing and slices. Before starting chapter 4, it's better to refresh pointers, stack and heap. First, let us refresh pointers to understand dangling reference and garbage collector. I used Replit for online C compiler with editor. Here I create a variable var1 with value 22 and prints the address of var1 and the value of var1, and then print the value that is stored in the address of var1. Here I used appropriate format specifier %p for address and %d for decimal value. Now run the program and see the result. Now I declare integer pointer ptr1 and assign address of var1 to ptr1. Then I print address of pointer 1 using format specifier %p and specified ampersand ptr1. Here ampersand with ptr1 denotes address of ptr1. And I print data stored in that pointer 1, and kindly note here I specified only ptr1 without ampersand. And then I print the address of var1 and then content stored in the data of pointer 1 and value of var1. Both are value 22. Next I assign value 11 to variable 1, and once again I print the address of ptr1 and data stored in ptr1 and content stored in the data of ptr1. Now run the program and see the result. Value changed to 11. Kindly note here we changed the value for variable 1 and access those values using pointer. Now this time I changed variable value by assigning value to *ptr1, that is content stored in the data of pointer 1. Then I print the value and address using var1 and ptr1. So from this program we can access value of variable using variable's name var1 and address of variable ampersand var1 and data pointer *ptr1 and address pointer ampersand ptr1. Next, let us see about scoped variable access and dangling reference in C. Here I created an integer pointer ptr1 and created a block scope. Inside of scope, I created variable var1 and assigns value 22 and prints its address using ampersand var1 and value using var1. And once again, print the value of var1 using asterisk ampersand var1, that is pointer to address of var1. Then I assign address of var1 to ptr1 and print the data and address and content using ptr1. I do these things inside block scope. Once again I changed value of var1 and print its address and value. Then I close the block scope. After that I try to print the address and value of var1 outside of block. It shows error because var1 is defined inside block scope. We know that, so I commented these two lines. But now still I can access value of var1 using pointer1 because after closing the scope, the place in which the value of variable stored is left as orphan. This is called as dangling reference and it can be accessed using pointer and also from other spywars. In olden days, that is from Windows 7, XP operating system and 95, Windows 95, Windows 98, there are many spywares to reveal passwords. I showed one of its image. Once again, I like to show dangling reference for characters in C. Here I created a character pointer and created a scope. Within that I created variable of char array named pwd with value password 007 and print its address and value using variable pwd. As like before, I assign the address of pwd as a data or content of character pointer ptr1. Then I print data and address and content using pointer variable. Here I used while loop to get single character from char array. And on each loop I increment pointer memory location, that is address. In line 27, once again I restore pointer location to point the starting address of char array. In line 29, I changed the value of pwd to new pass. This will overwrite on existing value and print the value of pwd in two types and run the program and see the result. As like the previous program, I tried to access the value of pwd and it shows error. So once again I tried to read these memory location using pointer and I can do it because these memory location values are not reclaimed by system. This is dangling reference. And these dangling references are collected using garbage collector, and these memory locations are reused by other programs. This arises many issues and memory leakages and performance degradations. Languages like Java, C Sharp, Go and many are used as garbage collectors. This is where Rust shines. Rust don't use garbage collector by its wise design. Ownership and borrow checker plays a vital role to reclaim unused memory locations immediately after the variable loses its scope. Like these types of wise design, Rust uses small amount of memory and CPU power and low binary size. You can check it from Rust in production page and read many testimonials. Thank you.